Ja, vad är klockan?
Okay. En minut.
Jag sätter mig där nere. Du får vinka åt mig om det börjar bli panik så kommer jag springa ut. Ctrl L för att maximera programmet. Du får lämna orkesterlådan ute tills du börjar prata.
Hello, everybody. Day one is almost over, but we have one last talk left. This talk is entitled Runtime Kernel Patching for OS 10. The speaker is Torbjorn Lufterud. I believe I pronounced that close to correct. He is filling in for the speaker who could not make it. He actually has the swine flu and is in the hospital. But this speaker is the co-author, the replacement speaker is the co-author of the FRAC article that is the basis for this talk. So I will turn it over to him.
Thank you
very much. Give him a warm welcome. Thank you.
All right. Thank you very much. As you've already heard, I'm not Bosse, but I'll do some PowerPoint karaoke here with you and try to use these slides to kind of fill, and you have to excuse me if I'm unable to fill in the gaps in his slides. And I'm also going to tell you right away that I will not be able to run the demos that he has prepared. So I'm obviously not Bosse. My name is Torbjörn Lofterud, and I work for a Swedish company called Cybercom. I also have somewhat of a more healthy fetish for breaking stuff. But we're here to talk about Mac OS X and runtime kernel patching. The first thing we're going to do is talk a little bit about what a rootkit actually is. Then we're going to talk about the usual way of doing kernel patching in the Unix environment. And then we're going to talk about some of the specific parts about using Mac OS X. Then we have a short proof of concept. And then we're going to talk about detection and have a Q&A. So, what is a rootkit? Well, a rootkit is something that you use once you've actually been able to hack into a system or gain access to a system. It is not an exploit. It is not a Trojan horse. It's all about stealth. It's all about hiding your activities and hiding your presence in a system. The main focus is often about hiding files and hiding processes. For instance, your backdoor or your sniffer that is running. You can hide sockets, and in many cases, you use it to hide or obscure your presence in an already exploited or hacked system. There are 2 or perhaps 3 different types of rootkits. We have the standard userland rootkits, which was popular in the old days. They replace binaries in the file system, usually processes involved with displaying files, processes, network sockets, and these types of utilities. With the introduction of advanced tools like Tripwire, we can be used to monitor system integrity. These these tools are not efficient anymore. It's very easy to detect. It's very easy to remove, and if you, especially since there were a number of standardized toolkits that can use for this, it's very easy to detect these kind of rootkits. So, for this reason, we move into the kernel and we write kernel rootkits. These rootkits do basically the same thing. They hide the presence of a backdoor or of a sniffer or some kind of other dubious process. There have been a number of really good rootkits for the Linux environment and also for Mac OS X and for Solaris. There's also a number of rootkits for Windows. We would like to mention Phalanx by Rebel, Swedish guy, Suckit, of course, Knark by Creed, also a Swedish guy, and Weapon X by Nemo, which was the first rootkit that I looked at for Mac OS X, which also inspired me to investigate this further. These rootkits use different technologies. For instance, Phalanx and Suckit both do memory patching using /dev-kmem on the Linux platform, while Knark and I believe Weapon X also are kernel modules. And this talk is basically about memory patching. So, I'm just going to change. So, what about the Mac OS X kernels? Mac OS X is a Unix-based operating system. It supports, it is built up by different modules. At the lowest layer, there's the Mach kernel. And on top of that, we have we have the BSD sublayer. These different components handle different kind of problems or different part of the operating system. The BSD layer handles networking, processes, and the POSIX subsystem, and the Mach kernel or the Mach layer handle things like processes and kernel threads, interrupts, memory management, and scheduling. And the interesting part for us here is memory management. The kernel, or the Mac OS X kernel, supports loadable modules. And if you're interested in how to create kernel modules or kernel module-based rootkits, I would really like to recommend our FRAC article on the subject. But this is not why we're here. We talk about direct memory patching for the Mac OS X kernel. We want to subvert the kernel without using loadable kernel modules. And we want to hook system calls and change their behavior in order to stay hidden. We can also manipulate other type of structures in the kernel, but we'll look into that later. So, whenever you have a process that is running in user space that wants to invoke something inside the kernel, it will call on a function. And what we want to do is that we want to intercept these function calls and change the output of the function. If you have a program that calls, I think in this example, it's function A calls function B, we want to intercept that function